NCERT.com Science 8. Chapter 5. Exploring Forces.
Force and its effects. A force is an interaction, commonly a push or pull, that occurs when at least two objects interact. This interaction can change an object's state of motion by bringing it out of rest or to a stop, changing its speed or direction. The direction of the push or pull defines the direction of force, often represented by arrows. When multiple forces act on an object, the result depends on their direction. Same direction, forces add up. Opposite directions, the net force is the difference between them. In a tug of war, the rope moves toward the stronger force. If forces are equal, it remains stationary. Effects of force. Force can cause the following effects on the objects on which it is applied. Force can change the speed of an object. Force can change the direction of motion of an object. Force can cause change in the shape of an object. Balanced forces. Balanced forces are equal in magnitude but opposite in direction, resulting in a net force of 0. When forces are balanced, an object's motion remains unchanged. If it is at rest, it stays still. If it is moving, it continues at the same speed and direction. For instance, a book on a table stays put because gravity's downward pull is countered by the table's upward push. Similarly, if a push is exactly resisted by friction, the object won't budge. Force works due to interaction. Force never acts in isolation. It requires an interaction between at least two objects. In every scenario, one object exerts the force while the other receives it. For example, when kicking a ball, your foot applies the force and the ball reacts. Similarly, rowing involves oars pushing water, which in turn pushes the boat. Without this dual object relationship, force cannot exist, be noticed, or be felt. Unit of force. The standard SI unit for force is the Newton, N. It is defined as the force required to accelerate a 1 kg mass at 1 meter per secant square. Another common unit is the kilogram force, kgf, which is the force needed to lift a 1 kg mass. The relationship between these units is 1 kgf equals 9.8 N. To measure force, we typically use a spring balance, which operates on the principle that spring extension is proportional to the applied force. Types of forces. Forces are classified into two main categories based on whether objects physically touch. Contact force. This force occurs when objects interact through direct or indirect physical touch. It can change an object's speed, direction, or shape. Examples include stretching a rubber band, pushing a window, or hammering a nail. Muscular force. A specific type of contact force, muscular force, is generated by the contraction and relaxation of muscles. It allows us to perform daily tasks like carrying bags, climbing ladders, or pushing a car. Animals also use muscular force to pull carts or carry loads. Friction. Friction is the force that opposes the relative motion between two surfaces. It is caused by the interlocking of microscopic irregularities, grooves and ridges, on contacting surfaces. Rougher surfaces create more interlocking, thus increasing friction. Types of friction. Static friction operates when an object is at rest. It is equal and opposite to the applied force until sliding begins. Sliding friction acts when an object is already moving. It is slightly less than static friction because contact points have less time to interlock. Friction depends on surface smoothness and how hard the surfaces are pressed together. Without it, objects like a suitcase on a moving train would simply slip away. Advantages and disadvantages of friction. Advantages. Friction is essential for daily activities. It provides the grip needed to walk without slipping, allows tires to move vehicles on roads, and enables brakes to stop them. Without friction, tasks like writing with a pen or holding objects would be impossible. Disadvantages: energy wastage. Significant fuel is used just to overcome friction. Heat generation. Friction produces heat that can damage fast-moving machinery. Wear and tear. It gradually wears out shoe soles and machine parts. Changing and minimizing friction. Increasing friction. To prevent slipping, friction is increased by making surfaces rougher. Examples include grooved tires for road grip, spikes on athlete shoes, spreading sand or gravel on slippery ground. Reducing friction. Friction is minimized to save energy and reduce wear through. Lubrication, using oil, grease, or graphite. Ball bearings by wheels. Rolling friction is much lower than sliding friction. Streamlining, giving objects, like planes and fish, a narrow front to reduce fluid friction, drag. Other contact and non-contact forces. Other contact forces. Beyond friction and muscular force, other contact forces include spring force, exerted when a spring is compressed or stretched, example, in toy cars. Tension, a pulling force transmitted through strings, ropes, or cables. Air resistance, friction exerted by air that slows moving objects, like a falling parachute. Non-contact forces, these forces act through space without physical contact. Key examples are gravitational, magnetic, and electrostatic forces. Gravitational force. Gravitational force is a natural attraction between bodies and a key non-contact force. The Earth's gravity pulls all objects toward its center, regardless of physical contact. Key effects. Vertical motion causes dropped objects to fall and slows down upward moving objects until they reverse direction. Weight. It gives objects weight by attracting them to Earth. Orbits. It keeps the moon orbiting Earth and planets orbiting the sun. Magnetic and electrostatic forces. Magnetic force. A non-contact force exerted by magnets on other magnets or materials like iron, nickel, and cobalt. Like poles, north-north, south-south, push away, repel. Opposite poles, north-south, pull together, attract. It is used industrially to separate iron scraps for recycling. Electrostatic force. This non-contact force is exerted by stationary electric charges. For example, rubbing a comb through dry hair charges it, allowing it to pull bits of paper from a distance. Weight and mass. Mass is the constant amount of matter in an object, measured in kilograms. Kilogram. It is a scalar quantity and remains the same everywhere in the universe. In contrast, weight is a vector quantity representing the gravitational pull on an object. Calculated as weight equals mass multiplied by gravitational acceleration 9.8 meters per secant square on Earth. Weight changes based on location. Measurement tools. Spring balance measures weight, N, by the stretch of a spring. Beam balance measures mass, kilogram, by comparing an unknown mass against a known standard. Floating and sinking. Whether an object floats or sinks depends on the balance between two forces, gravity, pulling down, and buoyant force, pushing up. Sinking occurs when gravity is stronger than the buoyant force. Floating occurs when the buoyant force equals the object's weight. Principle of flotation. An object floats when the weight of the fluid it displaces equals its own weight. This explains why a heavy iron ship floats while a small nail sinks. The ship's hollow shape displaces enough water to create a balancing upward push. Key factors. Density. Higher liquid density, like salt water, provides more buoyancy. Applications. Submarines use ballast tanks to change weight, and hot air balloons rise because they are lighter than the surrounding air. Buoyant force, or upthrust, is the upward push exerted by a liquid on any object placed in it. This force directly opposes the downward pull of gravity. Weight, floating, occurs when the upthrust equals the object's weight. Sinking occurs when the weight exceeds the upthrust. Buoyancy is the property of liquids to lift objects, and it applies to all fluids, including water, oil, and juice.